Thank you for joining us today on EarthFile. Welcome to the program. I'm Ayola Kasim. The use of fuel wood has created a series of environmental degradation. The severe loss of farmlands and poverty among rural dwellers are pointers to these problems. So there is an urgent need to adopt sustainable energy use to stop significant environmental and climatic changes which affect wealth creation among rural dwellers. Today on EarthFile, we'll look at the options available for users of fuel wood and charcoal. Just stay with us. Toyin Agbaje likes her kitchen. She's particularly more excited about cooking now because of her new stove, a biogas-powered stove which reduces air pollution and makes life in the kitchen a lot healthier.
The biogas is clean the pot, then fast. If you cook stew in the biogas, it's fast down stove, like normal gas. The biogas fast down normal gas.
The cooking gas used is produced from cow manure by a researcher at the Obafemi Awolowo University in Ile-Ife, Osun State.
Here at the cattle section of the Obafemi Awolowo University agric farm, where the university, the agric faculty have their cattle, where they do the research on the cattle, and we are using the manure from the cattle to produce biogas, because what they do with the manure is they just dump the cow manure, the manure from the cow somewhere at the back of the shed here, and the manure decomposes and it releases methane to the environment, which is a greenhouse gas and is not good for the environment. But we are here to use the cow manure as a source of feedstock for our biogas plant, where we use the manure to transform it to biogas, and the biogas can be used for cooking and energy production. So in a way, we are trying to mitigate pollution and indirectly climate change.
Biogas refers to a mixture of gases produced by the decay or fermentation of organic waste like sewage, kitchen waste, animal manure, food scraps, and plant material. When all this organic waste is allowed to decay in the absence of oxygen, methane, carbon dioxide, and some other gases are produced. Methane is the most important of all the produced gases because it is a very valuable fuel. Methane is a popular natural gas that is used for heating, lighting, and cooking purposes in the home. Experts say we produce and waste large volumes of biogas every day without even knowing it. Every time the toilet is flushed after use, or the kitchen dirt is washed down the sink, valuable raw materials needed to produce biogas is being wasted. For ages, cow's excreta traditionally has been used as manure in the fields, but they are also a source of viable energy biogas, which is capable of providing electricity for domestic purposes. One cow can produce over 30 gallons of manure a day. 100 cows can produce about 30,000 gallons of manure. All that manure can be turned into serious energy generation process for powering electrical equipment for various domestic purposes. Cow dung is used in many developing countries for generating energy. It has a lot of potential to reduce carbon footprint. By capturing and storing carbon dioxide from biogas into the ground, the biogas becomes carbon negative and scrubs past carbon dioxide emissions out of the atmosphere. Cow dung gas has between 55 and 65% of methane, 30 to 35% of carbon dioxide, 1.8 to 2.4% nitrogen, between 1 and 1.2% phosphorus, and between 0.6 to 0.8% potassium, and also 50 to 75% of organic humus. About 1 cubic foot of gas may be generated from 1 pound of cow manure at around 28 degrees Celsius. Around 1.7 cubic meters of biogas equals 1 liter of gasoline. The manure produced by one cow in 1 year can be converted to methane, which is the equivalent of over 200 liters of gasoline. Once the manure has been collected, it is taken to the biochemical engineering laboratory where it is preserved and stored ahead of conversion.
Preserve it in the freezer because we don't use everything that we collect in a day, and we need to keep the temperature very low so that the bacterial activity will not go on, and if that goes on, it will affect the quality of the manure. So we preserve the manure in the freezer around about 3 to 4 degrees Celsius. So where we need it, we take it out, we weigh the amount we need, and we take to the reactor to feed the reactor. And this design is the Chinese dome reactor, because it was initially invented. It was invented by the Chinese, and we have the one we are optimizing. So we have the normal Chinese dome reactor. Then this is the optimized design, which we have tried to improve. We are trying to improve the honest design of this reactor. So now, after collection of the manure, the reactor volume is about 500 liters, and the two of them, they are 500 liters. So we have amount of waste that we had into the reactor daily, which is about 12 kg with 4.6 liters of water daily. So we do that into the two reactors, and we also take out from the reactor. Most of the biogas reactor, they normally put a lot of water, they dilute with a lot of water because it makes it flow easily in the reactor. But what we are trying to do here is we want to add very little water so that to conserve space, and because if you conserve space, you won't have a lot of investment. So what we are trying to do, we want to try to halve the size of the reactor. We want to halve the size of the reactor, and so that we can still have the same efficiency. So what we want to do now, we want to feed. This is the inlet of the reactor, and this is the outlet of the reactor. And we collect our gas from here into the gas bag, and we measure the volume of gas that is collected every day. This is a gas chromatograph machine, and the purpose, the use of the machine is to help us to analyze our gas from our reactor, which is the biogas. It helps us to check the quality of our methane and our CO2, and also to check if our reactor is performing very well. This does the same work as the chromatograph by telling us the percentage of methane, the quality of our gas. The feed that goes to the reactor stays about 30 days, and every day it produces gas, and the gas is collected, and the waste here that is collected, the effluent which has produced gas that have the potential of the biogas has been exhausted to a large extent. It's a very good manure, and which is what we have here. We try to preserve it outside, and this is what we have here. And these are good organic fertilizer which can be used. You can apply it on your farm.
Although the process of producing biogas is an unpleasant one, biogas could be an effective and productive use of waste. It's simply a win-win situation.